In this video, we're going to go over how to look at different resonance structures and know which resonance structure is best. Okay, and there's a few rules, and then we'll rank the rules, and then we'll do some practice problems. So rule number one is that we want to minimize charge. The best kind of structure is one without any charges. It is acceptable to have one or two charges, but structures with more than two charges should probably be avoided. Okay, so this structure is best, this first one, because it's neutral. And then if we look at these guys would be both okay. They wouldn't be the best, but between these, this would be second best because more bonds. Okay, so we're going to be able to rank a lot of these using multiple rules. More bonds is going to be more stable. Forming bonds releases energy, thus forming more bonds releases more energy. And throughout chemistry, you should learn that molecules prefer to reach their lowest energy state. Okay, and so we get something that looks like this. This would be best simply because more bonds. If elements are in the same energy level, then highly electronegative atoms are better to hold negative charges. And so if we go through and we do some resonance, and this guy has 5 resonance structures, so I won't draw all of them. We get something like this. This is best because the negative is put on the most electronegative. And then I would add that carbon and nitrogen are in, or I should say they occupy the same amount of energy levels. Okay, if elements are not in the same energy level, then the larger atom will be able to hold any charge. Okay, so if we look here, we do formal charge. We have NCS, so negative, neutral, positive, negative. 1, 2, 3, 4, 5, 6, negative. This is -2, actually, -2, which is very rare. You almost never see that. This would be the best because the negative is put on the largest atom, okay? So you'll typically see a sulfur or a chlorine or something like that that's not in the second energy level when something like that comes up. Now, more substituted carbons can better hold positive charges. So we need to be able to know the difference between primary, secondary, and tertiary. So if we have something like this versus this versus this is secondary, primary, tertiary. Why? The carbon holding the positive charge, I've marked with a little dot, and those could be positive or negative charges. It doesn't matter as far as primary, secondary, or tertiary. Ask yourself, how many other carbons is that carbon attached to? Okay, this guy is attached to 1, 2 carbons. This guy's only attached to 1, and this one's attached to 3. And so that's where the naming system comes from. Okay, so if we draw resonance structures here, I'll get those drawn. It'll take me a second. we get tertiary, secondary, primary. This one is best. And then this one is worst. Okay, because the rule is more substituted carbons can better hold positive charges. With negative ones, we have less substituted carbons can better hold negative charges. So again, arrows look a little bit different for negative charges. And so, let me get this resonance drawn. We get something that looks like this. This guy is secondary, tertiary, secondary, tertiary. These guys, both of them would be best, okay, because they are less substituted.